Today we're going to continue putting together the fact that we've been talking about slopes and rates of change and direct variation. It's all going to kind of come together in this. So the first type of problem that they give you is 3 pumps are pumping fluid at a constant rate. Now remember, constant rate is really talking about your slope. So for each, the amount of fluid pumped depends on your time. So they give us 3 different pumps. And the reason they do this is they give us 3 different versions of finding slope. Find slope off of an equation in pump A. Find slope off a table in pump B. Find slope off a graph in pump C. Pump A is the easiest. When given this equation, what is the rate, or in other words, the slope of that pump? Say it again. 110. The number that is multiplied, usually it's an x, but the number that is multiplied there is your slope or your rate of change. Okay? B, how do I find the slope or the rate of change in a table? Jacob?
You count how many two squares.
Very good. It's your swoops, right? 0 to 1, you. 1 to 2, you. 2 to 3. Then we go on the other side, 0 to 120. 120 to 240. 240 to 360. Now, question of the morning, which one goes on top? 120 over 1, which is 120. Just like you did on Monday in your 3-1 worksheet, and even on Tuesday in your book assignment as well. Pump C, you're given a graph. The easiest way to find the slope on a graph is to find points on that line. Somebody who has not answered, give me a point that is on that line. That's a perfect point. Chris. Very good. 1, 90. How about a second point? Nevaeh. 2 and 180. Now we get to use our slope formula, reminding ourselves x, y, x, y. Y on top. Which y value you want to start with? 90 minus 180 divided by 1 minus 2. 90 minus 180 is negative 90. 1 minus 2, negative 1. Negative 90 divided by negative 1. A negative divided by a negative is a positive. 90 divided by 1 is 90. All you're doing are looking at your different slopes, your different rates of change. Okay? So the second question, they say, now that you know all those rates, which pump is the fastest? B. How do you know that? Very good. It's your highest rate. It's the largest number. It means it's going to be pumping the fastest. So all of those rates were over 1, or in this case, per hour. The last question on this asks us, how much does it pump in 2 hours? Well, how am I going to figure out what pump A does in 2 hours? You could add a second hour to it or multiply by 2, because sometimes they might say like in 5 hours or in 7 hours. So if you take your rate from up above per hour, and you're going to go times 2. So 110 times 2 is 220. Pump B was 120 times 2, which is 240. Pump C was 90 times 2, which is 180. So that problem's super intimidating, but it's just finding slope from different forms. Okay? Direct variation equations. Y equals mx. Have a constant of variation or a constant rate of change. For each table, determine whether it shows a direct variation. If it does, write the direct variation equation. I'm going to tell you, this is the problem. People are like, what? Miss Hoff, I keep getting this problem wrong. I don't know why, because they're not writing the equation. If I want to figure out if we have a constant rate of change from a table, we're looking at the swoops. 5 to 15 is plus 10. 15 to 25 plus 10. 2 to 6 plus 4. 6 to 10 plus 4. Which one goes on top? 10 over 4, 10 over 4, which is good. They're the same, but we got to reduce 10 over 4. Really is divide by 2, and you would get 5 over 2 and 5 over 2. So yes, this is a direct variation equation. Okay, or yes, it's a direct variation because those are the same. So the equation, instead of y equals mx, you would write for this one y equals 5 over 2x. This right here is the equation. So many people just write 5 over 2 and they're like, I don't know why I got it wrong. Well, you just gave the slope. You didn't give the equation. You're going to have a y. You got to have an equal sign. You have your slope, but then also your x. Okay? Let's try the next one. Now, this one, they start with a decimal, so we're going to work with decimals, and Miss Hoff's okay with that. What is my change from 1 to 1.5? Plus 0.5. 1.5 to 4? Plus 2.5. 2 to 3? Plus 1. 3 to 5? Plus 2. So which numbers go on top? Okay, so what would your fractions look like? Now, 0.5 over 1 is over 1, so we know we can't reduce that. Because they're a decimal, actually divide 2.5 divided by 2. 1.25. Is this a direct variation equation? No, these two are not equal. You do not have a constant rate of change, not a direct variation. So you don't have to write the equation because it's not even a direct variation. If your two rates of change do not match, not a direct variation. All right. Back page, we're going to work on those equations, writing direct variation equations. Now, I was impressed. You guys did pretty well with that, and even looking as I was walking around while you were grading, it was pretty good. But we're going to fine-tune our skills to make sure we can be consistently good at it. We can use direct variation equations to find unknown values. Suppose y varies directly with x. Okay, y varies directly with x. That's a key phrase that indicates to us that we get to use y equals mx. So then it says y equals -12 when x equals 9. Write a direct variation equation. Let's start there. Direct variation equation. We start with y equals mx. Start with the information they give you. What's y? -12. M's going to stay m because I don't know what it is. What's x? 9. How do I solve for m here? Divide by 9. Now, if you type that into your calculator, you get a decimal. You don't want a decimal. Ms. Hoff does not want a decimal. So we need to divide something out of both of these. A 3? What do you end up with? Don't lose your negative. Don't lose your negative. -4 over 3. Now, don't quit here. You have to write the direct variation equation, which would be what? So many people forget x. A lot of people write m equals -4/3. Well, they didn't ask what m was. They want the direct variation equation. Now, part 2 goes on to say, find y when x equals 4. So we keep our equation, y equals -4/3 x. Find y when x equals -4. Do I replace y? No? Do I replace x? How do you know? Yeah, it tells you x is -4. It says find y. We don't know what y is, so we can't replace it. So we're going to put in -4 for x. And because -4/3 is a fraction, I'm going to put -4 over 1. Anything in the top and the bottom that you can simplify? Nothing? Okay, top times top. Bottom times bottom, 3. Now, Alex will already have y equals. All you have to type in is that 16/3. 16/3. Again, people get this wrong because they don't write the whole equation. All right. Suppose y varies directly with x. Y equals -6 when x equals -14. Write a direct variation equation. Start there again. Put this information together. Whoopsies. Y equals mx. What's y? -6. We don't know m. What's x? -14. How do I solve for m? Divide both sides by -14. Now, a negative divided by a negative is a positive. 6/14, or 6 divided by 14, is a decimal. What can I divide out of both? 2, you said? So you end up with 3/7. Somebody who has not answered for me, what can you tell me my equation is? Did I already call on you? Go ahead. I'll let you go anyway. Say it again. Y equals. There you go. I heard somebody help you. Don't forget the x. Don't forget the x. Okay, part 2. Find x when y equals -4. Find x when y equals -4. Somebody tell me what's different about this problem. Lane? Yeah, they tell us to find x this time. Every other time we've been finding y. And as Gatlin pointed on the last one, you know you replace x because it said x equals. Well, in this case, this one says y equals. So you got to read really carefully about which letter you're replacing. So now I know y is -4. -4 equals 3/7 x, and I need to solve for x. This takes us back to chapter 2, solving equations, specifically 2-1, when our coefficients were fractions. How do I get rid of a fraction coefficient, Chris? Ooh, careful. You times it by 7/3. The reciprocal. Nicely done remembering the word. You multiply by the reciprocal, or the flipped fraction, 7/3. Because they cancel, and I have just x remaining. Now, 7/3 times 4, or -4, I'm going to put it over 1. Anything cancel or reduce? Okay, 7 times -4. -28. 3 times 1. 3. So we have to be really careful because they may ask us for x, they may ask us for y. Same process, especially the beginning. The beginning is identical. Just pay attention to what information they give you. Question, sir?
So for that one for the second,
Mm-hmm.
you're dividing the fractions, which is why you flip it.
Correct. So technically right here, you're multiplying, which really then you would divide by 3/7. But the way of dividing by a fraction is to multiply by the reciprocal. Yep. All right, this last one, everybody panics on. They're like, words. It's got words. I can't do it. This process is identical to what we just did in the last 2 problems. They just don't say here's x and here's y. They use other words. Okay? According to Newton's second law of motion, the force acting on an object varies directly with the object's acceleration. That phrase we have seen so many times the last 2 days. Up here, y varies directly with x. Y was in front of that phrase, x was behind the phrase. So if we go down to this, the force acting on an object is our y, and the object's acceleration is the x. Because they talk about force before the phrase varies directly, that's our y. They talk about acceleration after, that's our x. So Miss Hoff comes down here just to keep herself sane and organized, and I remind myself, whenever they talk about force, they're really talking about y. Whenever they talk about acceleration, they're really talking about x. Suppose that a force of 24 newtons results in an acceleration of 8 meters per second. Wait a minute, we just said force was what?
24.
What did we say force was?
Y.
Y. So really, they tell me I have a y value of 24. And an acceleration of 8. Acceleration is x equals 8. Every other problem we had an x and a y, we could write the direct variation equation, the first part of this. So let's do that. Direct variation equation starts with y equals mx. What did you guys just tell me y was? 24. I don't know what m is yet, but what is x? 8. How do I solve for m? Divide by 8 on both sides. M equals, ooh, we like this one. 3. It's a whole number. It's always nice when it's a whole number, right? What's my equation then? Y equals 3x. So the last part of this then says the acceleration becomes 3. What'd you tell me acceleration was? So x is 3, and they say, what is the force? Force is y. We don't know what y is, aka find y when x is 3. So we take our equation, y equals 3x. Do we know y or do we know x? We know x. X is 3. So what is y? 9. The force is 9 newtons. Now, I'm going to be very honest with you. They don't always give you acceleration at the end. Sometimes they give you force and ask you to find the acceleration. That's why it's so important to write down what is force, what is acceleration, what letter means what. The biggest thing today is writing the equations. Make sure you have a y, make sure you have an equals. Flop your m out for whatever your slope is. Make sure you have an x. Okay, don't yell at me, but we're going to do it one more time today because I'm still having people not catching updates. Log into your laptops, go to your desktop, close out of everything and leave it open. Then go grab your paper. I'll let you know when you can log into Alex. I won't do it after this week to everyone, but we got to still get some updates going.